Hi, everybody. Hope you're enjoying your e-learning and all your classes. Today we're going to do the average rate of change. Again, but we're going to talk about different ways that slope can answer questions. So not just finding rate of change again and again and again. Your homework does have a good amount of practice with that, just like the backside of your homework last night. All right. Before we do this, though, in case you had a question on your homework, trying to think back, I usually have questions on number 2, so I thought I'd go through that one. If you don't need help with this one, feel free to fast forward through this. It says, find the average rate of change for the function f of x equals natural log of x from x equals 1 to e. So this, just so you know, from x equals 1 to x equals e, could be written like this if it was interval notation. Okay, so I want to find the coordinates so that I can find the average rate of change. So I'm going to say the natural log of 1, and I'm going to say the natural log of e. Okay, remember this is base e right here. So in order to evaluate, it's saying e to the what power equals 1, whereas this one is saying e to the what power equals e. Okay, remember anytime these two are the same, the answer is always 1, but this also shows why the answer is 1. Okay, so this one's going to give me a coordinate when x is 1, e to the 0 power gives me 1, so 1, 0. And this one's going to give me the coordinate when when x is e, or the input is e. E to the what power is e, and that would be e to the first. Okay, so using those two coordinates, I would say 0 minus 1, so change in y, and my x is 1 minus e, so I get negative 1 over 1 minus e. So there's really not anything I can do to simplify this. E is an irrational number. So leaving this as negative 1 over 1 minus e is the most simplified answer. I could factor a negative 1 out, and that would leave me then with 1 like this. But I don't really need to factor that out. Same thing. It's not really factoring out. It's just moving it to the front. Either or is fine. Okay. I did want to talk about this one though. It said, which one did it say? Draw a sketch of the function hint factor. This is factoring by grouping because there are 4 terms here. So out of these 2 terms, I can take out an x squared. So I'm going to take an x squared out, and that's going to leave me with an x plus 2. And here I can take out a negative 1. So if I factor out a negative 1, that's going to leave me with x plus 2. And remember, these must be the same in order for this to factor by grouping. That's going to leave me with x squared minus 1. I'll group those together, times x plus 2. Okay, by factoring, I can figure out what my solutions are. My solutions here, if I were to solve this, would be x squared minus 1 equals 0. So x squared equals 1, take the square root, and that's going to give me 2 solutions, so it's going to give me plus and minus 1, and then this one's going to give me a negative 2. So to draw a sketch of this function, I would say here are my 3 x-intercepts. I have one at negative 1, one at negative 2, and one at positive 1. If I look back up at this function, this had a leading term that was positive, and it's an odd. Remember, odd has opposite behaviors if you think all the way back to Unit 1 to start the year. What that means is that it's going to go through here, and through here. Notice it has opposite end behaviors because it was positive, it started down and finished up. Okay. It says use your sketch to check your answers for A, B, and C to make sure that they seem reasonable. All that's doing is really checking. I want you guys to check and see if your answers should be positive versus negative. So like this one's from negative 3 to 1. So let's see. So this is 1 right here. Negative 3 would be somewhere over here. So it'd be like all the way down here. So that should give me a positive answer. So you should have a positive answer for A. B is from negative 1 to 0. So let's see. Negative 1 to 0 would be right here. So that is, and I can actually see that that's a slope of, well, actually, I don't know what that is. I know it's negative. I don't know what this answer is right here. That's just an estimate. So that should be a negative answer. And then last, let's see what number C said. C said -2 to 1. So this is -2 and this is 1, so that should have had a slope of 0. Okay. All right, on to today's. Let's see. All right. If two lines are parallel, what are their slopes? Give an example. So if two lines are parallel, sometimes drawing the example helps to start. That means that the lines would have to look something like this. Parallel means that they never intersect. So that would be like if this slope is 2, then this one would also have to be 2. So what are their slopes? Whatever they are, they have to be the same. Okay. If two lines are perpendicular, what are their slopes? So perpendicular means that I would have something that looks like, let's say I have a line here. Perpendicular would mean that it would hit here such that when they intersect, it makes a 90-degree angle. Okay, so that would mean that if this line had a slope of, let's say, let's say 2/3, positive 2/3, this one would have to have a slope that is the opposite and reciprocal. So I'm going to say opposite and reciprocal. And those questions tend to pop up a lot on the SAT and ACT, just talking about understanding that perpendicular lines have opposite and reciprocals. So opposite is referring to this is positive, this is negative, and reciprocal, it means if this is 2/3, flip it, that's 3/2. Okay, and the next one, if two lines are neither parallel nor perpendicular, what are their slopes? So if they're neither parallel nor perpendicular, all it means is they're intersecting lines. So like this and like this. Like I could say that this slope is 0, and I could say that this slope is 3/2. Um, so here's your example. It just means that their slopes are numbers that are not the same because that would make them parallel, and they're not opposite and reciprocals because that would make them perpendicular. So they're just two slopes that are different. Okay. In the first two examples, we want to determine if the lines are parallel, if they're perpendicular, or if they're neither. Well, in order to determine if they're parallel, perpendicular, or neither, we need to know what their slopes are. Because if their lines have the same slope, then they're parallel. If their slopes are opposite and reciprocals, they're perpendicular. And if they're just two numbers that are neither of these two, then they're neither parallel nor perpendicular. Okay, so I have line 1 and line 2, which means I need to find two slopes. So slope for line 1, I'm going to say m equals, I need to subtract my y's, so -3 minus 1, excuse me, and 4 minus a -8. And then for line 2, I'm going to say m equals, subtract my y's, so 11 minus 20, and 5 minus 8. All right, this is going to give me -4, and it's going to change to a plus sign, so it's going to give me 12. So this simplifies to -1/3. Okay, so -1/3 is that slope. Over here, I'm going to have -9 and -3, which equals +3. Okay, if I compare these two slopes, they're not the same, which means they're not parallel, but they are opposite and reciprocal. So I'm going to state that opposite and reciprocals. Okay, again, opposite, this one's negative, this one's positive, and then reciprocals. That means that these lines are perpendicular, and you can use this notation. So this would be my answer. Okay. And the next one, this would be a good place for you to pause and you to try this and see what you get for both of them so that you can compare them. All right, let's see. M equals 1 minus 6, 4 minus -8, and equals, so this is for line 1, this is for line 2. Let's see, we have 4 minus -8, and 2 minus negative 1. So this changes into a plus sign, so does this. So 4 plus 8 is 12. Negative 2 plus 1 is negative 1. So this means that my slope is negative 12. Up here, I get negative 5 over, this changes to a plus sign, over 12. So there's my slope for the first line, there's my slope for the second line. If I compare them, they're not opposite because that's negative and that's negative. They're clearly not the same. So these are neither. So neither parallel nor perpendicular, and this is the notation we use. So they're just intersecting lines. All right. Number 6 says, is the average rate of change greater from negative 9 to 4 or 3 to 7? The only way to answer this question is to find the average rate of change for both so that then we can compare them, okay? This would be another place where it would be nice for you guys to pause and try it on your own. But before you pause, notice that we have a table of values. So from negative 9 to 4 means that we would be using this coordinate and this coordinate. So table of values are always nice because it gives the answers, gives you the coordinates. And then from 3 to 7 means we'd be using this coordinate and this coordinate. Okay, so like I said, good place for you to pause and try this on your own. All right, let's see. So this is for the first interval. We're going to say m equals 330 minus negative 112 over negative 9 minus 4. Okay, and then over here, I'm going to say m equals negative 78 minus 170 and 3 minus 7. All right, so let's see. And we're going to use our calculator for number 7, so feel free to use your calculator for this. I just have to find it here. Okay. When you put this in, make sure you put parentheses around your numerator and denominator. So 330 minus negative 112, you can also put plus, divided by negative 13. That's going to give us negative 34. Okay, over here, we have negative 78 minus 170. And you guys should be doing this too. Just make sure that you're putting this in your calculator correctly. Negative 4. And we get 62. All right, so I got a rate of change of negative 34 and 62. The negative does not matter. All the negative means is that we're going down 34 versus up 62. So don't think about it as like negative 34 is smaller than 62. We just care about 34 is smaller than 62. So which interval has the greater rate of change? We're going to say the interval 3, 7 with m equals 62. Okay. Again, you can't make this and have it justified unless you actually find the rate of change for both so that you can compare. All right, next one says, given the three functions, notice we have f of x, we have g of x, and we have h of x in the table. Determine which has the greatest relative maximum for the interval 4, 10, and justify your answer. So in justifying your answer, it just means that you need to find the relative maximum for all three of them again so that you can compare and determine which one has the greatest relative maximum. It's called a relative maximum and not a maximum because it's just at this window from x equals 4 to 10. So it's not necessarily the maximum for the function, but it is for that interval. Okay, and it's not very practical to do this without a calculator, so we actually are going to use our calculator for this. So if I go to y equals, I'm going to clear out what's in there. I'm going to put negative 0.5 x squared plus 8x, and make sure you guys are putting this in too. Okay, and I'm actually just going to put one in at a time. And to make sure all of our windows are the same, go ahead and hit zoom, and then go down to number 6 where it says standard. That way everybody's window looks the same. So there's my function. I know it's quadratic. I know it's negative, which means it goes up and it comes down too. So I need to change my window to make sure I fit it. I need to go higher. And I also need to go to the right farther. So instead of going to the right 10, I'm going to go 30. And then my max is at 10, I'm going to go 50. And I'm going to hit graph. I can see there's my function. Okay, I can figure out what that maximum is by, let's see. Actually, and I only care about the interval from 4 to 10. So I'm actually going to change my window to that. So my y or my x min, I'm going to say 4, and my max, I'm going to say 10. That way I'm only looking at this window. Okay, and I can see it's obviously somewhere in here. What I can do is calculate the maximum. So if you hit second trace, I'm going to calculate the maximum here. So I'm going to hit enter. It's going to ask me for my left bound and my right bound. So I'm going to go left over here. You can see, look at your y values at 31.8. I can see that they're going down. So I'm going to hit enter. And as I go to the right, watch these y values. It's at 31.4. I can see it's going up right now. It hits 31.88, still going up, still going up. It never hits 32, and then it starts to go down. So I could keep going right here, but I can see that now I've surpassed the maximum. So I can hit enter, and then I hit enter again, and it's going to tell me that that maximum is at 8, comma 32. So I'm going to state that here. So I'm going to say max at 32. Remember, maximum minimums are not coordinates, so we don't want to say 832. We do want to notice, though, that 8 is between 4 and 10. If it was outside of that, then we couldn't use it. All right, my next function, I'm going to say y equals 8, and then square root. Oops, so it's out 8 square root of x plus 3 minus 2. And make sure you put it in correctly. And then I'm going to leave my table of values where it's at just to see if it works. I'm going to hit graph. I can see my function's going up, 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 and it looks like it's actually still going up. All right, so the problem with this function, I'm actually going to go back and I'm going to hit zoom 6 here. I can see that my function just kept going up here, so I'm going to change my window a little bit, and I'm going to change the maximum, let's say, oops, not the x, I'm going to change the y maximum to 50. I can see my function keeps going up, and you can see that it's going to continue to go up. It's just going to keep going up. It's a square root function. It's going to continue to increase. All right, what that means is at the x value of 10 must be the biggest number. So all the way over here is the biggest, because otherwise it's just going to keep going up, 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 up to positive infinity. So what I can do is I can go to my table of values, and I can just go to 10, because that's going to be the maximum for that interval. So then I can state here that the max is at 26.84. Okay, so out of these two functions so far, this one's winning. This one, here's my x value of 4, all the way to my x value of 10. So this table is my exact interval. I can see that this height right here is my highest height. Everything else, once I reach that, gets lower, 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 lower. So I can say then that this one has a max at 48, which is the highest. So which function was the question? Determine which function had the greatest maximum. It's this one with the max at 48. So h of x is the function that has the highest maximum at 48. All right. All right, go ahead and flip over. All right, what do we have here? It says Peter the penguin, Wally the whale, and Dennis the dolphin. So we got a, let's see, we have a penguin, we have a whale, and we have a dolphin are performing in a show where they leap out of the water. Let x be the time in seconds and y be the height above the water in feet. So just to give you kind of an idea here, sketches are always nice. Here's my time in seconds. And here's my height. You guys should be writing this down too. And above the water, and this is in feet. Okay, so what that means is that this right here is a height of 0. And obviously the animals are swimming below, and what they're going to do is they're going to hit the surface of the water, they're going to come out, they're going to hit the surface of the water, they're going to go back in. Okay, the functions are kind of complex here just to try to make this seem somewhat realistic. And then we're just going to get at some key features here. It says which animal jumps in and out of the water the most. What's helping you determine this? So before I go ahead and graph these, which animal jumps in and out of the water the most? Well, if we had an animal down here that was doing this, wouldn't that be going, we're under the water, we're out of the water, we're under the water, we're out of the water, under, out? So what's going to help us determine this is actually the x-intercepts. So these right here, because when we hit that x-intercept, we're leaving the water. When we hit that x-intercept again, now we're coming back into the water. So x-intercepts are actually what's going to help us answer this question. So x-intercepts. All right, now we have to determine which one. So take your calculator, and we're actually going to put all three of these in at once. Take your calculator and put all three of these in, and be very careful that you put them in correctly. Otherwise, your function will look totally different. Okay, so I'm going to pause this and I'm going to put mine in so you don't have to watch me put it in, but take your time. Okay, so hopefully I put them in correctly to help us here. I took my time and I made sure that I double checked every single one as I went through, so feel free to pause this and just double check. Common things that we miss are x's. We'll put like negative 0.5 raised to the fourth instead of x raised to the fourth. So make sure you have x to the fourth, then x to the third, then an x squared, then an x, then your constant. Just kind of go through, make sure your signs are correct. We get errors if we try to put a negative sign here. The calculator does not accept that as a negative sign. It's got to be minus 15. Whereas here, this must be a negative sign, not a minus sign. Even though they're interchangeable, the calculator doesn't read them that way. Okay. So if we hit, I'm going to go actually, and I'm going to change my window. I'm going to hit zoom 6. So this is what everybody should get. If you don't get this, you're going to want to go back and change your function and make sure that they're all correct. This right here, that first one is the penguin. This next one is the dolphin right here. And this last one is the whale. Okay, we're looking specifically for the interval of 0 to 8, which is why I actually don't want to go any farther than this, because this goes to 10 anyways, and I think that stops right there at 8, which I can see. Let's see. So that x-intercept, yeah, is at 8. Okay. All right, so x-intercepts are going to tell us how many times something jumps in and out. So I'm actually going to, this is what I'm going to do. I'm going to change this back to 1, and then it's going to regraph this whole thing so we can count as it goes. So the first one is the penguin. All right, so let's see, the penguin goes out, under, so let's see, it goes out once, twice. So 1, 2, 3, it has 4 x-intercepts. It's going to take a while, but I'm going to say P of x has 4 x-intercepts, T of x, and W of x. Okay, and I'm going to do that same thing again because it's kind of hard to see as once they're all on there. So we'll count again. There's 1, 2, 3, 4. And there's 1, 2, 3, 4. In that window, notice that there was 4. I can't count this one over here. And the last one just has 2. 1, 2. So this one has 4. And this one has 2. Okay. So what that means in terms of jumping is if both of those have 4, it's going 1, 2, 3, 4. So in terms of jumping in and out, so which animal jumps in and out of the water the most, these two are the same number of x-intercepts. So it's jumping out once and again. So it actually jumped out twice, whereas the last one only jumps out once. So which animal jumps in and out of the water the most? It would be the penguin and dolphin. Okay, it doesn't ask us how many times, but we could say with 2 times compared to 1 time. The next one says which animal jumps the highest. What's helping you determine this? Well, highest is talking about a maximum. So maximum. And again, we're specifically looking for that interval of 0 to 8. Okay. Let's see here. I can do this based off of my graph. So I'm going to again do this. I'm going to see here that the penguin doesn't get very high. So the penguin gets this high right here. I'm going to leave my cursor there. The dolphin gets way up there. We have no idea where it's at, but we can go figure it out. The dolphin's way up there, and the whale's right here. So the dolphin definitely got the highest. We just have to figure out how high. So I'm going to change my maximum, my little window. I'm going to change my Y max to 20. It's going to regraph all this. All right, so I know that it's up there, and I actually don't need to see it. I can definitely see the dolphin got the highest. If you go ahead and hit second calc, we can hit maximum. And what we need to do is we need to jump on that function. If you notice right now I'm on the penguin. If I hit the up arrow, it switches functions. I'm on the dolphin right now, or I'm actually on the whale right now. If I hit up again, it's going to jump functions again. And notice now I'm on the dolphin. So I'm right here. So what I can do is I can hit enter. That's my right bound. And now it's going to click over. Or sorry, that's my left bound. I'm going to hit right until my cursor comes back down. And there's my cursor. I can hit down one more time, and it's there, and hit enter. And now notice it's finding the highest point between those two values. If I hit enter, it's going to tell me that my maximum is at 5.34, 23.37. And remember, maximum is the highest height. Which animal jumps the highest? So we're going to say the dolphin. At 23.37. I don't know if a dolphin can actually get that high, but it's pretty high. All right. Next question, not last question, but next question. Let's see. Ben and Jerry are at the top of a hill, top of a tall hill. They're about to run down the hill to get an ice cream cone at the bottom. Their paths are shown below, where X is time in seconds and Y is the height above the ground in feet. From the interval 2 to 5, which this is talking about 2 to 5 seconds, right here, who is moving faster on average? Well, this is talking about an average rate of change, so I need to find the average rate of change for both functions. All right, so interval from 2 to 5. So I'm going to substitute a 2 in. That's going to give me negative 1/2. 2 plus 5 is 7. And 2 minus 8 is negative 6. So that means when x is 2. This is, let's see, I remember I can do this. This makes it easier. Half of 6 is 3. Negatives cancel out. 3 times 7 is 21. So that's my first coordinate. If I substitute a 5 in, 5 plus 5 is 10. And 5 minus 8 is negative 3. So when x is 5, let's see, this is negative 5 times negative 3 is positive 15. So m equals 21 minus 15 over 2 minus 5. So I get 6 over negative 3, which means my average rate of change for that interval is negative 2. Okay, so negative 2. And the negative should make sense because he's running down the hill. All right, next one, Jerry, so j of x. So we're going to have to substitute in again. So when I substitute in a 2, let's see, 2 plus 4 is 6. So this is going to be the square root of 6 plus 50. And the square root of 6 is not a nice number. So at this point, you can see that this would be a calculator question. And I'm going to put this into while I'm going, and I'm going to say negative 15 times the square root. If I substitute in 5, 5 plus 4 is 9. That one will be nice. Plus 50. So when x is 2 and when x is 5, I'm just going to use my calculator for both. So I'm going to say negative 15 times the square root of 6 plus 50. And I'm going to go ahead and do the same thing, but I'm going to change the 6 to a 9. So that gives me 13.26 and 5. So that was nice. So I'm going to get m equals 13.26 minus 5 over 2 minus 5. Oh man, and 2 minus 5. So that's going to give me, I'm going to put this in my calculator. So 13.26 minus 5. And again, you guys should be doing this. Don't just watch me. That's going to give me that m is about negative 2.75. Okay, let's go back to the question here. Let's see, who is moving faster on average? So going down negative 2.75, which means this one is happening faster. Okay, remember the negatives are just direction. So we're going to say Jerry. That was J of X. So Jerry with m equals negative 2.75. By stating it like that, I'm justifying my answer. I'm showing that what my answer is. Okay, good, good. All right, the last two are just for extra help with trig as well as log, just because trig, it's been a while, and log, it's good review from last unit, especially since we haven't taken that test yet. All right, so good place to pause and try this on your own. You should definitely be able to do this function since it's a log. This one you may need to watch just because it's probably been a while. Let me get this out of the way. All right. So let's see, with this trig one, we need to substitute in, and we're actually going to have to add a little bit. So I'm going to say sine. When I substitute this into here, it's going to be pi over 3 plus pi over 3. That means that it's going to be sine of 2 pi over 3. Okay, and then the next one, it's going to be sine of, I need to substitute this into here. So it's going to be sine of 2 pi over 3 plus pi over 3, which means it's going to be sine 2 pi over 3 plus pi over 3 means it's 3 pi over 3, which means that it's just sine of pi. Okay, so if we draw out our unit circle, 2 pi over 3, remember 3 means that it's talking about 60 degrees, and I want 2 of them. So 60 degrees would be here. Okay, so right here, this is talking about a y value. So right here, my height is root 3 over 2. So I'm going to say, okay, with an input of pi over 3, my output is root 3 over 2. But I need to determine if that's positive or negative. 2 pi over 3, if that's pi over 3, 2 pi over 3 is here, which means that the y value is still positive, so that's good. When my input is 2 pi over 3, my output, let's see, pi is here, and my y value, my height is 0. So there we go. So then I can find my average rate of change by saying root 3 over 2 minus 0 divided by pi over 3 minus 2 pi over 3. So my numerator is root 3 over 2. The denominator, fortunately, they have a common denominator. So 1 minus 2 is negative pi over 3. I want to multiply by the reciprocal, which would be negative 3 over pi. Okay, nothing's going to cancel here. So that means that my rate of change is negative 3 root 3 over 2 pi. Okay, so hopefully that's good review for trig, and we take our final. All right, over here, again, pause it, try this problem. This is log. This would be really good review for your test. So let's see here. This is going to be log base 1/2. When I substitute a negative 6 in, that's going to give me negative 6 squared is 36. Remember, it's positive. So 36 minus 4 is 32. Okay. Over here, I'm going to substitute in a positive 6, so this will be log base 1/2. When I substitute in a positive 6, I'm going to get the same thing. Since 6 squared is still 36, 36 minus 4 is 32. Okay, remember that this, when I evaluate, it's doing this. So I'm saying 1/2 to the what power equals 32. And this one's going to say the same thing, so I'm not going to rewrite it. I want to raise this to a negative power in order to flip this to give me a 2. Okay, I could also do this. I could say 1/2, or I could say that 1/2 is the same as 2 to the negative first power to the what power. So 1/2 is the same as 2 to the negative first. And then over here, I can say 32 is the same as 2 to the fifth power. Okay, so that means I want to know negative 1 times what equals 5. So divide by negative 1, and that's going to give me a negative 5. So that means when my x value is negative 6, I'm going to get an output of negative 5. And that also means when my x value is positive 6, I'm also going to get an output of negative 5. Okay, I use those coordinates to find my average rate of change. So I'm going to say m equals negative 5 minus negative 5 over negative 6 minus 6. Well, negative 5 plus 5 is 0, and negative 12, which means my average rate of change is 0. Okay, don't say undefined. Undefined would be if there's a 0 down here. All right, so that's it. Your homework. Let's see, you're going to have some more problems with are the lines parallel, perpendicular, neither. You got a problem that's much smaller than what we just did in our notes. Only 2 functions, but still kind of goes through those same questions. Okay, and then I threw some really good SAT questions on here. There's always a lot of SAT questions that have to deal with average rate of change. So like this one right here, and then this one right here. Okay, in some way, shape, or form, they're getting at average rate of change, or it's just something very similar to average rate of change. It's a good place to talk about it. The backside, I made totally review of the first thing, where you're just substituting in, finding your coordinates, and then using your slope formula. Okay, notice you have a sine function, a cube root function, log function, rules of exponents, cubic, cosine, tangent, rules of exponents, so a lot of good review. All right, and again, guys, if you have any questions whatsoever, email me. We can hop on a Google Meet. I can answer your questions. Okay, the last thing that we want is for you guys to come back and be confused and say, oh, I didn't get it, and I didn't get it 2 weeks ago. Because I'm going to say, well, why didn't you talk to me, right? We have lots of time off. We can't leave our houses really, so ask, okay? Keep learning, keep keeping up. While you do have time to do all these things, don't put it off, okay? Make sure that we're ready to go. I also highly, highly suggest that if you guys have not worked through the test review for the logarithmic functions unit 4A, or sorry, 4B, work through it. Okay, if you haven't yet, finish it. Try to make sure that it is done by the time that we come back. That way, when we come back, I'm not reteaching you stuff, but I'm answering questions on things that you didn't get. Okay, and unfortunately, it's inevitable that you're going to forget stuff. But if you've gone through the test review, it should come back pretty quick. Reteaching is a totally different story. Okay. All right. Well, good luck. Let me know if you guys have any questions. Have a great day.